Hi students, so today's session is going to be on your work power and energy. Alright, now let me give you a brief of what I am going to do in my today's session and how is it very important from your JEE perspective, right? Now students, you must have seen that repeatedly over the years, alright, there have been questions which have come in work power and energy. But let me tell you, the trend which has been for the questions in work power and energy, it has been a question which is kind of not very complicated. They are based on basic concepts. So the problems that I have taken for my today's session, they are actually based on your easy concepts, or you can say your fundamental concepts of your work power and energy. They are rather, I would say, not very simple, but very logical. So I have divided my work power and energy into two parts. Part number one, I'm going to deal with the basic concepts. The questions will be on the basic concepts. And in the next session of your work power and energy, we are going to do more of problems that involves your work energy and work energy theorem. Alright, so in today's session, we are going to look at mostly the questions which are work done by variable forces, alright, or let's say how to calculate work if you have a force and a displacement graph, alright, and towards the end, okay, we are going to look at some previous year's questions from the same topic, that is your work power and energy. So let us get started with our today's session. So students, those who are watching me for the first time, my name is Sumit Kundu. I am a BTech graduate from IIT Bombay, which I would say secured a rank of 2125, had 10 years of experience into teaching, alright. Before that, I did involve myself into something else, about which we can talk sometime later. And I have been training students, lots of students, alright, different kinds of students who are in the top rank holders to medium rank holders, and also to students those who have been preparing for let's say your CET or NEET or any other examination. Alright, so that is a brief intro about myself. Now students, moving ahead, one thing is very important here. The ones who are watching this channel, alright, let me tell you, there are other channels also, like you have got your Unacademy JEE channel and Unacademy NEET channel, and you have got the foundation channel as well. Okay, now here when you go to this particular URL, that is tinyurl.com/JEEmobile, you will see, as you can see out here, you will see that every lecture, like units and dimensions, if you see, you have lesson 1, lesson 2, lesson 3, so you can play it. So it's an archive of all the chapters that has been conducted in the previous year. Along with it, you will also get the PDF notes of these lectures. So if you are looking for some solid content, alright, in order to prepare for your final minute JEE, this is the best place that you can actually go to. Not just physics, chemistry, maths for 11th, physics, chemistry, maths for 12th standard as well. Okay, so it is going to be really very helpful for you students. Now, moving ahead students, let me tell you, if you haven't subscribed to the Unacademy Plus, go ahead, subscribe for it and use the code SMLive. You will right away get a 10% discount. So students, let's begin with our today's session. I know you, all of you, lot of you, okay, have your examinations, physics examinations on Monday, that is your board examinations. So definitely best of luck for that, and that too it's physics, okay, but you definitely have your 12th standard syllabus. So best of luck, God bless you with all the efforts that you are actually putting into. And students, those who haven't come live here for today's session, definitely it's going to be there in the recorded format, so you can check it out after your physics examination or whenever you are preparing for the mains. Fine. So let's have our first question. Okay, now I'm going to start off with a very basic question, All right, now here what do we have, and we'll unveil the concepts behind these questions. So the question is like very simple. It says that there is a force of minus I cap plus 2j cap plus 3k cap Newton. Alright, so this is the force which is acting, and it is acting on a particle, and because of this force, this particle moves 4 meters along the z-axis. Alright, and we need to find out what is the work done. Very simple question, right? So let's go ahead and solve this particular question. Simple it is, that is the force is equal to minus I cap plus 2j cap plus 3k cap, and displacement is equal to, it is 4 meters along the z-axis. It is how much? 4 meters along the z-axis. So I can say displacement is 4k cap. Now we know that work done. What is the work done? Simple thing. It's the dot product of force and displacement. It's a dot product of force and displacement, right? So you just need to find out the dot product out here. That is, work done will be equal to F dot S. So this will be simply minus I cap plus 2j cap plus 3k cap dot 4k cap. Dot 4k cap. So out here K will go with K. We don't have components of I and J in the displacement, so that is going to be equal to 0. Simply 3 into 4, it will be 12 joules. Alright, simple question, but yes, everyone must know this particular central idea behind the chapter, that is, work done is equal to the dot product of force and displacement. Fine. So students, let's move ahead to the next question. Very good. A lot of you have given the answers, and yes, that is the correct answer out here. Alright, so here we have our next question. Students, in JEE Mains, let me tell you, in JEE Mains, if there is a question coming to find out the work done, see, we have work done by constant force, we have work done by variable force. Definitely, they're not going to ask you a question where it is going to be work done by a constant force. It's going to be very, very simple. Okay. But they go ahead and ask you questions in which you need to calculate the work done by variable force. So we are going to look at two different questions, and similar kind of questions have come in the JEE Mains. Alright. So those two initial questions, I'm going to do it for you. And after that, we are going to look at the question from the JEE Mains, which is there from this particular topic. Alright, so here we have a particle which moves along the x-axis from x equals to 0 to x equals to 5 meters. Alright, now under the influence of the force is given by 7 minus 2x plus 3x square. So whenever I see it's a function of x, or I see it's a function of time, I know my force is going to be not a constant force, but rather it is going to be a variable force, right? Now, what is the procedure to find out the work done by a variable force? So there is a general formula to do this particular question. Okay, so the work done will be integration of F dot ds from initial position to final position. Alright, now my ds alright is equal to what? Now this particle is moving only along the x-axis. See, my particle is moving from x equals to 0 to x equals to 5. So it is only moving along the x-axis, right? So I can write my ds vector as equal to dx. Alright, actually let's try and understand this. My ds vector is generally written as your dx I cap plus dy j cap plus dz k cap. Alright, but here the force vector is along the x-axis. If you can see it, it's a function of x. 7 minus 2x plus 3x square. Alright, so we do not have any component of force along the y direction or any component of force along the z direction. Simple enough. So when you do a dot product of I cap with this, you are going to be left out with only dx. Alright, so I can write down here my dw as equal to 7, excuse me, just a second, I can write it down as 7 minus 2x plus 3x square into dx. Alright, because the force is along the x-axis and the displacement dx is also along the x-axis. So when I take a dot product, the angle between the force and the displacement will be equal to 0, and cos of 0 degree is always equal to 1. Alright, so if you have to find out the total work done, all you need to do is integrate this, right? It's as easy and simple as that. From where to where? From 0 to 5, because the displacement is from 0 to 5, right? When you do the integration, simple. See, it is going to be 7x out here minus 2x square divided by 2 plus 3x cube divided by 3. From where to where? 0 to 5. Simple enough. So let's solve this. We'll get 7x minus x square plus x cube. Alright. And if you put down the values, you will get 7 into 5, 35. Alright. Minus x square. So minus 25 plus x cube, that is 125. Right. If you solve it, 35 minus 25 is 10. 10 plus 125 is 135. Alright, so students, option C here will be the correct answer. Alright, very simple questions, right? Now, good job, Sanathan. That's a really quick answer, I would say. Your name is Keshav. Good, your name is Keshav. Alright, fine. So now, let me come to this question. Alright, students, who says that in JEE Mains your questions are not repeated? Alright, if someone is telling you that in JEE Mains questions are not repeated, it is not true. Okay, though for JEE Advanced, I would say definitely the questions do not get repeated. Alright, for JEE Advanced, the questions do not get repeated and it's always a surprise in the JEE Advanced. But if you are looking forward to boost your score in JEE Mains, alright, I would suggest go ahead, do the past 10 years questions, alright, from the JEE Mains archive and previous to that from AIEEE, alright. Definitely you will see that your rank for the April paper is going to go up, alright. It is to be done not just for physics, chemistry and mathematics. Now if you look at this question that I am talking out here, almost a clone kind of a question has actually come in the JEE Mains 2019. Alright, we look at this question. Let me analyze this question for you. Very simple. See, you need to understand these kind of trends. You need to really work smart also. Alright, see, under the influence of some force, alright, there was a 2 kg body which was moving in such a way that its position was changing as per this formula out here. The position of the body was changing as per this formula out here, where x was in meters and time t was in seconds. We had to calculate the work done by the force in the first 2 seconds. Okay, so this is a question from a book, I'll tell you later, from Comprehensive Physics actually, alright. And then in 2019 this question had come. In 2019, exact clone, just that they have changed this x. Even the mass is the same, 2 kg. Out there also it was 2 kg. You see here x was 3 some t cube divided by 3. Here x is equals to 3t square plus 5. And we need to find out the work done by the force in the first 5 seconds. There it was, what was the work done in the first 2 seconds. Alright. So which question do you want me to do? Do you want me to do the previous question or do you want me to do this question? Because I am going to do only one out of these questions and I'll leave the other question to be done by you students. Alright. So which one do you want me to do? The JEE Mains question? Fine. So let me do this one. Okay. So let's try and understand what is being asked in this question. It's x is equal to, so it has been given that x is equal to 3t square plus 5. Okay. So dx by dt can be written as what? 6t, alright, differentiate this, plus 5. 5 is a constant, so if you differentiate it, you will get something equals to 0. Now this is what? This is equal to velocity. So acceleration will be what? dv by dt, that will be equal to 6 meters per second square. Now we can observe that acceleration is constant. Acceleration is equal to constant. So what will be the force that will be acting on this body? We know force is equal to what? Very simple, students. Force is equal to what? It is equal to mass into acceleration. Force is equal to mass into acceleration. See, such a simple question, okay, coming in JEE 2019. Now this is going to be force is equal to mass, that is 2 kg, into acceleration, that is equal to 6, that is going to be 12 Newton. Alright, now what is the next step that you are going to do? You need to find out the work done, right? You need to find out what is the work done. Fine. So there are two methods of actually doing it. You need to understand that this is going to be a constant force that is acting on this particular body, right? So if you find out the total displacement, in 5 seconds, you can just multiply it with the force and you will get the work done, right? So what will be the displacement, right? So displacement will be, initially the body was at rest. If you see here that v is equals to 60, so time t equals to 0, if you put it, v will be equal to 0. So initial velocity of the body is equal to 0. So s will be equal to half into a into t square. So this can be written as half into a, acceleration is 6, into time square, that will be 5 into 5. Simple idea. So this will be 3. 25 into 3 is going to be 75, and the work done will be equal to 75 into 12. All right, simple idea. 12 into 5 is 60, 6 carry, 12 into 7 is going to be 84, 84 plus 6 is going to be 90. All right, so 900 joules is the correct answer. Got 4 marks in your JEE mains. Such a simple question. 2019, not a paper which was like in the years 1999 or things like that, where paper were relatively much simpler. But yes, 2019, and yes, the question is very, very easy and you could have scored 4 marks right away. All right, so here option B is the correct answer. Clear? Now, though there is a little bit, okay, of a, let me go back to the last question. Here, if you see, there is a little bit, rather this question was a little bit tougher. Okay, I mean, I wouldn't say much tougher, but little tougher, all right, as compared to the question which appeared for the JEE mains, right? Why was it tough? Simple thing. See, try and understand here that x is equals to t cube by 3. X is equal to how much? T cube divided by 3. So if you had to find out the acceleration here, if you had to find out what the acceleration here, what would it be? See, velocity will be dx by dt. So when you solve it, you will get 3t square divided by 3, that will be equal to t square, and acceleration will be dv by dt, so that will be equals to 2t. All right, so force would be mass times acceleration, so that will be equal to 2 into 2t. 2 into 2t would be equal to how much? 4t. Try and understand this concept. Very simple. See, in the question that we did, my force came out to be a constant force. The force was a constant force. Here the force is a variable force. So you need to deal with this particular thing very importantly, and it is not very difficult, I would say. All right, rather it is simple. So how would you deal with it? Okay, if you have to find out the work done, right, it would be integral dw. All right, now integral dw will be equal to f dx. Dw is equals to nothing but f dx. We have seen it in the second question that we did today. So here, try and understand this. F is equal to what? F is equal to 4t. F is equal to 4t. But I need dx. Right? So from this relation, what can I write my value of dx? What can I write the value of dx? The value of dx can be written as t square dt. So I can write here dx as t square dt. So this expression will become 4t cube dt, and we need to find out the work done in how much time? From 0 to the first 2 seconds. So 0 to 2. Alright, we can easily integrate this. What would this be like? 4t to the power 4 by 4 from 0 to 2. Just apply the value and you will get your answer. Alright, just apply the value and you will get your answer. Yes, a lot of you have given me the correct answer. Option B, I think. Yes, 16 is the correct answer. Good job, guys. If you have done this, be confident that you will be able to crack if a similar question comes in the examination. Alright, now let's move ahead to the next concept. Okay, so this is something that you have already done. Now here, a little bit of a revision that work done in if a graph has been given to you. Okay, if a graph has been given to you, then how do you find out the work done? Simple, eh? Okay, how do you do it? See, the graph is between force and displacement. It is between force and displacement. Simple concept is work done. Like I'm getting a feeling, I'm getting a hunch that if this year there is a question coming from work, power and energy, somehow it is going to be graph related. And if it is really graph related, okay, do come back to me and let me know. Alright, you can always put down the comments on the day of your JEE if there is a question on the graphs. Somehow, I mean, like, you know, teachers, they do get an intuition. That looking at the trend of the questions for so many years, alright, we do get an intuition that yes, maybe this year there is going to be at least one question on graph if it is coming from your work, power and energy. Alright, chalo, let's have a look at this particular question. What does it say? We need to find out the total work done between 0 and 8. That is, when the particle moved from x equals to 0 to x equals to 8, what was the total amount of work done? Work done, we know, simple. It is the area. It is what? It is the area under a force displacement graph. So this is a force, this is displacement. So this is a force displacement curve. Now remember, whatever area is above the x-axis, we take it as what? We take it as positive. And whatever area is below the x-axis, we take it as negative. Simple idea. Okay, whatever work is above the x-axis, positive. Whatever area is below the x-axis, it is going to be equal to negative. Simple idea. So what will be the area out here? We need to find out the total work done. So try and understand, this is going to be 20 plus 20. All right, this is like 10 and this is like 2. Now this height is 10, so this area will be equal to half into base, that is 2, into height, that is 10. So this is going to be 10 plus 10, and if you look at this, it is going to be again half. Base is 8 minus 6 is 2 and height is how much? 5. So this is going to be minus 5. What will be the total work? 20 plus 10, 30. 30 minus 5 will be equal to 25. Simple thing. Okay. Option B. So most of my answers for today, if you notice, is coming out to be your option B. That is out here 25 joules. Alright. Chalo guys, I think a lot of students have actually got it right. Okay, as I can see, Sanathan is solving all the questions from the very beginning itself. He is kind of glued to the channel out here. Good job. And I can also see Mehak Soni. Mehak Soni, good job. You have done really well for this particular question. Now we are going to go to another fundamental concept of your work power energy, which a lot of students, they generally tend to overlook. All right. Now, let me tell you two things, students. See, consistently, every year questions have not been coming from work power and energy in JEE Mains. All right. Let me be very frank with you regarding this. Then the question is, sir, why is it so important to study? I mean, like, is it also important to study this particular chapter for my JEE Mains? Well, I'll say yes, definitely yes. Point number one, why should you study? Number one, that if there is a question coming, it is not going to be very difficult. It is going to be easy. So scoring is going to be much easier for a question which is coming from work, power and energy. Okay, so you should take your chances for studying this particular chapter. All right. Number 2, why should you study this particular chapter for your JEE Mains or revise it for your JEE Mains? See, simple understanding. There are a lot of questions. Listen to this very, very carefully. All right. There are a lot of questions in your Newton's law of motion, which if you do by using the Newton's law principle or any other principle where there are a lot of springs and like, you know, those multiple spring systems and all of those things, okay, pulley springs, blah, blah, blah. Now, they are pretty elaborate. They have pretty elaborate solution. Matlab, long solutions are there. All right, if you solve them by the Newton's law method. But when you solve these questions by work energy theorem method, okay, when you solve these questions by the work energy theorem method, then they get solved in like, you know, 2 steps, 2 or 3 steps maximum. So you are going to save your time, for questions of Newton's law if you do this particular chapter. So that is the second reason that you must do this or take this chapter very, very seriously. There is also a third reason. All right. What is the third reason? Simple understanding. You will understand it from the next question itself. Okay. The third reason is, if you look at other chapters, all right, not just work, power, energy, but if you look at your chapter of gravitation, your chapter of electrostatics, or your chapter of magnetism in 12th standard, everywhere we use the concepts of your work, power, energy. Everywhere we are using the concepts of your work, power, energy. So that's the reason why this chapter is like very, very important. So I've given you 3 solid reasons that why this chapter or studying this chapter is very, very important for the preparation of your JEE examinations. All right. Acha students, now let's move ahead to the next question. Acha, let me ask you, all of you, a simple question. Okay. Let me ask a simple question to all of you. Now, is work or energy, or is work and energy reference frame dependent? That is work or energy dependent on the reference frame? Let me see the answers coming up in the chat box. Let me see the answers coming up in the chat box. Is work or energy reference frame dependent? Right? So let me just see. Yes, some of you have said yes, it is. All right, it is true, it is reference frame dependent. Now, what is the simple concept behind it? Let me just share with you one small analogy. All right, see, simple understanding is, let's say I have got an elevator which is moving up with a velocity v. I've got an elevator which is moving up with a velocity v. Now, if I see there is a person out here who is watching a block, okay, which is placed inside this elevator. This person is seeing this block which is placed inside an elevator. All right. What would he see? Let's say this has got a mass of m. Right? He would see this block is actually in motion. And if I ask him, this guy out here, if I ask him, Acha, tell me what is the kinetic energy of this body? He will say it is half mv square. All right. However, let's say I have got another person who is sitting inside this particular elevator. I have another person who is sitting inside this elevator, and I go ahead and ask him, Acha, you tell me that what is the kinetic energy of this block? You will say the block is at rest. So the kinetic energy of this block will be equal to 0, isn't it? So who is lying or who is telling the truth? Both are telling the truth. Work or energy is basically dependent on the reference frame. All right, students. So this is the central idea behind the next 3 questions that I'm going to do with you, or let's say the next 4 questions that I'm going to do with you. It's a very, very important concept from the JEE Mains perspective. All right. Chalo, so let's get started with this. All right. Let me just rub off everything out here. So that's what it is. Okay. Chalo. Now let's have a look at this question out here. Simple thing. There is a block. Let's try and understand, and let's try and focus on this question. It's a beautiful concept that you must carry away with you guys after today's session. There is a block of mass 10 kg. It is acted upon by a force of 100 Newton. So 100 Newton force is acting on this 10 kg block. definitely if 100 Newton force is acting on this, there is going to be some acceleration and this body is going to move, right? So if there is one person A, okay, we need to find out how much will be the work done calculated by A. If the acceleration of A is 0 and A is at rest, okay, you have understood one logic that for different people work done is going to be different because work done is reference frame dependent. All right, for this person the work done is going to be different, so we need to find out what will be the work done by this person, okay, or let's say what will be the work done as seen by this person as per this observer, and finally we need to find out what will be the work done, all right, what will be the work done as observed by C. So the question is, if there is a 10 kg block and there is a force of 100 Newton acting on it, then what will be the work done as observed by A, B and C? That's what is my question. Okay, so we'll go ahead and do this particular question here. Chalo, let's have a look at this. So the first part, that is what will be the work done as per your observer A. Observer A is at rest, right? So anyways, we need to just calculate what will be the displacement of this block as compared to this observer out here, right? So he is going to see that 100 Newton is acting on 10 kg, so acceleration will be equal to how much? Acceleration will be equal to 100 Newton divided by 10. It will be equal to 10 meters per second square. Simple idea. So displacement will be equal to half into A, that is 10 into T square, right? So let me say that 500 is the displacement out here, okay. So by the way, displacement is also given. Wow, this is very simple. Rather, this is very simple. We don't even need to worry about the displacement, okay. Now we need to just worry that this person is going to observe how much displacement has taken place, right? How much displacement has taken place. Is going to observe 500 meters displacement has taken place. So as per him, the work done will be equal to simply 100 into 500. So this will be 5 into 10 to the power 4 joules. This was like very simple. This is the standard method that we all know so far. I mean, we have always placed our observer at rest so far and found out what is the work done, right? So option B is the correct answer. Now let me go ahead to the next part. In the next part, we need to find out what is going to be the observer B seeing. All right, see, the displacement is 500 meters. So how much amount, I mean, like, you know, what will be equal to the time taken to cover this much amount of displacement in the first case? All right, so I can say S is equal to half into A is equal to how much? T into half into 10 into T square, that is equal to how much? 500, right? So if you see this, 0 and 0 is going to cancel and T square is going to be equal to 50 into 2, that is 100. So time T will be equal to how much? 10 seconds. All right. So this body must have covered 500 meters in how much time? 10 seconds. This part is clear. All right. Now let us see this. Let us understand this, that what will be the displacement of block B or the person B in 10 seconds. He is moving with how much speed? 10 meters per second. So displacement of B will be equal to 10 into 10, that will be equal to 100 meters. Let's try and understand this. Okay. So what will be the displacement of this block with respect to the observer B? Displacement of the block with respect to the observer B will be displacement of block minus the displacement of block B, that will be equal to 500 minus 100. So this will be equal to 400 meters. All right. So as per him, what will be the work done? As per him, the work done will be equal to force into the displacement here, that is 400. So that will be 4 into 10 to the power 4 joules. All right. Did everybody understand? Simple concept. So here I have option B again as the correct answer. All right. So I hope everyone's got this particular question, right? Now, guys, this is also going to be very simple. Acceleration is 10 meters per second square. We know time t equals to 4 seconds. So in time t, if it is 4 seconds, then we can calculate what will be the displacement of c. All right, then we will find out the displacement of the block with respect to c and multiply it with 100 and get my answer. All right, so this was the logic, this was the concept that we have learned. Let us try and apply this on a JEE mains level question. All right, this was not your JEE mains level question, this was the concept that we have learned. Right, now we are going to go ahead and apply this concept on a JEE mains level question. Are you prepared? Are you ready? So let's get started here. We have got very less time left for this session. So this is the question that we have at hand. Now let's have a look at this question. Very simple. Okay. We have a trolley. On the trolley, I've got a 2 kg block. I've got a 2 kg block placed right away on the trolley. Okay. The trolley is moving with an acceleration of how much? 2 meters per second square. The trolley is moving with an acceleration of how much? 2 meters per second square. There is an observer. There is an observer. All right. Who is moving with how much? 5 meters per second square. He is moving with how much? 5 meters per second square. Let's try and understand the question right now. What is being asked here in the question? We need to find out what is the work done by the friction on this block as observed by this person. What is the work done by friction on this block as observed by this person? Game for it? Let's get started. See, simple idea. There are few data which is given to me. Trolley, remember, 2 meters per second square. Man, 5 meters per second square. Coefficient of friction between the block and the surface is 0.3. Okay, we need to find out the work done during the first 2 seconds of motion. We need to find out the work done during the first 2 seconds of the motion. All right, chalo, let's get started with the discussion of this particular question out here. This is a very, very interesting question, students. Let me tell you. Okay, acha. Sometime back, all right, sometime back, if you are really enjoying the session, do not forget to press on the like button, students. First of all, you look at that I have started this chapter with something really very, very basic, and we are growing up slowly in the concepts. All right, so if you're liking the session, if you're enjoying the session, you know what, you need to go ahead, press on the like button. Fine. So here we have, let me tell you the first concept first. What is the first concept? Sometime back, I asked you, work, energy, are they reference frame dependent? We figured out, yes, they are reference frame dependent. Let me ask you my second question. Is force reference frame dependent? Well, no, force is not reference frame dependent. Let me tell you, what is it that I want to say here? Simple understanding. If I want to calculate the friction acting on this 2 kg block with respect to this person, or with respect to an observer who is sitting inside the trolley, or with respect to an observer who is sitting out here in an inertial reference frame and watching the entire show happening, for all these people, the value of the friction acting on the 2 kg block, is going to be the same. This is a very important concept. Remember it. Force is not dependent on the reference frame, but work and energy are reference frame dependent. All right. Now, let me go ahead and let's calculate the friction first. Okay. So, with respect to which observer should we find out the friction? Okay. Let us find out with respect to this guy. Okay. Why? Because we will revise the concept of pseudo force also in the process. Right. Maximum amount of benefit, isn't it? See, this guy out here, he is sitting on a frame of reference which is accelerating. What is the first thing that comes to our mind? what is the first thing that comes to our mind? That there has to be a pseudo force acting upon the block that this person is observing, right? Pseudo force. Now the concept of pseudo force comes into the picture. Where does pseudo force act? In which direction does pseudo force act? It acts opposite to the direction of acceleration. So acceleration is happening in which direction? In this direction. Acceleration is happening in which direction? In this direction. So pseudo force will act in this direction. So let me write it as your FP. Okay, that is the pseudo force. So we will see that as per this guy, pseudo force is acting in this direction. So there will be a tendency of the block to move in this direction. So friction should act in which direction on this 2 kg block? Friction should act in which direction on this 2 kg block? It should act in the forward direction. Simple idea. Tendency of motion backward. So friction will be in the forward direction. Acha, next thing that comes to my mind, what will be the value of the pseudo force? What will be the value of the pseudo force? All right, the value of the pseudo force, very simple, will be equal to mass of the body being observed into acceleration of the frame. So 2 into 2 will be 4 Newton. Will be equal to 4 Newton. Students, lots of concepts are going to be discussed in this one question itself. So pay attention till the end. You will have all your concepts cleared. All right. Acha, chalo now. What is the maximum value of friction? What is the maximum value of friction? Will be equals to mu times normal reaction. Mu is 0.3. Normal reaction 2 into 10. 2 into 10. Acha, so this will be equal to 6 Newton. Alright, this will be equal to 6 Newton. Maximum value of friction is 6 Newton. Alright, how much pseudo force is acting? 4 Newton. The question comes to my mind, will the body move? Will the block move? No, the block is not going to move. If the block is not going to move, then how much will be the friction acting on this block? Friction acting on this block will be equal to the pseudo force, that will be equal to 4 Newton. Simple idea. Okay. Now what will be the displacement of this block with respect to this observer? See, acceleration of the block with respect to the observer will be acceleration of the block minus the acceleration of the observer. Revision of relative velocity also. Revision of relative velocity. One question. Lots of what do I call it? Lots of effort, or let's say lots of फायदा. ठीक है? कुछ words English में आता ही नहीं है. It comes only in Hindi. Right? So acceleration of block B with respect to the observer, I can write it as simply how much? 2 minus 5. That is minus 3 meters per second square. Right? So what will be the displacement of the block with respect to the observer? Displacement of the block with respect to the observer will be half into acceleration of the block with respect to the observer into t square. So that will be half into minus 3, and they have asked for how much time? Let's just look at the question once again. How much time? 2 seconds of motion. So 2 square, that will be 4. Multiply this 2 times minus 6 meters. So what will be the work done by the friction as observed by this person out here? It will be minus 24. Option D will be the correct answer. Students, if you have enjoyed it, do not forget to press on the like, share, subscribe. Okay? Acha. Now I want you people to do a exercise. I want you people to do a exercise on your own. A slight variation, okay, of this question. What is it? Do it yourself question. Right? Now in this question, the person is not moving in the direction of the trolley. Rather, he is moving opposite to the direction of the trolley with the same acceleration, and the trolley also has the same this thing. Okay. Now you need to find out what will be the work done by the friction. Again the same question. What will be the work done? Okay. Alright. So forget it. Forget all that. I am telling you the question. If this person is running in the opposite direction, then what will be the work done by the friction on this particular block as observed by him? I hope students you enjoyed this concept, and everybody who is watching this video right now has understood this question. And if you have understood this question, you know what? You need to press on the like, share, subscribe. All right. Chalo guys, now let's move ahead to the next question or the next concept. Now this question had come for your JEE Mains. This question. Now JEE Mains people, they know, they're very smart people. All right. They're not going to ask you questions. They're not going to ask you questions which will happen right away. Okay, there is going to be some twist in the question, because without that twist they are not going to enjoy, all right, the look on the face of the students. Right now here I have the earth, right? Now on the surface of the earth there was a body kept. Let me say this is the center, and on the surface of the earth there was a body out here. Now this body was raised in height to some height h. Now this h is equal to capital R. This h is equal to how much? Capital R. They asked us what will be the gain in the potential energy of the object. This has got a mass of m. Now if I ask you, simple thing, if I ask you what will be the gain in potential energy, the first thing that comes to our mind, acha, delta U, very simple, mgr. Simple. You answer this question, you get -1 in JEE Mains. They're not going to test you that this is going to be like, a right away cakewalk. Okay. That's not how you're going to do it. See, mgh, this formula has a certain limitation. Now, we generally use this formula for those cases where height is like very, very small as compared to the radius of Earth. Where h is very, very small as compared to the radius of Earth. Now, if h is comparable to the radius of Earth, right? If h is comparable to the radius of Earth, then we do not use this formula. Rather, we use the concepts that are there in the chapter gravitation. What did we learn about potential energy? All right, we know it is going to be equals to, if there is a block on the surface of the earth, we know the potential energy will be equals to minus G capital M small m upon R, isn't it? Now if I take it to a height h, so let me take it as U1. If I take it to a height h, it will be minus G M small m upon R plus h. Now here the value of h is actually equal to R. Okay, so if you place it and calculate delta U as U2 minus U1, you will get the value of change in potential energy as mgr divided by 2. Simple thing. Okay, so I hope students you have enjoyed today's session. All right, we have few other questions. Now these are very simple questions. It is going to be in the PDF notes, and I expect that these questions you will be able to solve on your own. Okay, हालांकि ये भी एक क्वेश्चन आया था 2019. देखो कितना सिंपल सा क्वेश्चन है. Let me explain to you the question. That's all I'm going to do. Okay, I'm not going to give you the solution for such a cakewalk question. All right, the question was like very simple. There is a block which is kept on a platform. All right, excuse me. It's kept on a platform and this was going up with an acceleration of g by 2. What will be the work done by the normal reaction in time t? Okay, what will be the work done by the normal reaction force in time t? That's all you have to find out. See, try and understand, students, why did I tell you that this is an easy question? Why did I tell you this is an easy question? Because they are asking us work done due to a constant force. Yeah, if you have to ask us to find out the work done at least by a variable force, I understand there is some challenge. But you're asking me for normal force, which is a constant force. Very simple. You will be able to do it. Okay. I just wanted to give you the exposure to the questions that has come in 2019. That's all. That was the only objective. Okay. Acha, here. Only the concept of work energy theorem has been asked out here. That is, work done is equal to change in kinetic energy. They said that there was a force, all right, and it created this much amount of displacement. The body initially had 3 joules of kinetic energy. So what will be the final kinetic energy of the body? All right, simple thing. Find out what is the work done. Work done will be equals to what? The change in kinetic energy, and you'll get your answer, right? So students, if you have enjoyed today's session, you know what you have to do. You have to like, share and subscribe. All right. Acha, students, important things. Now, if there is any question, Akash, when the time comes for the sprint for advanced, I'm going to take the sprint for advanced as well, and they are going to have some other types of questions, definitely not the type of questions that we did today. So as per the examination, we are moving forward. Okay, fine guys, very good. Mehak, absolutely correct. And also your Santhanam, okay. I have observed you students were there from the very beginning of the session, and I'm really sure that from these sessions you guys are really benefiting, all right, because if it was not excuse me, if it was not, you would not have been sitting here for the last 45 minutes trying to figure out what exactly to take away from this particular session. Okay, and the good thing is what, you know, you have solved and given right answers to a lot of questions, which shows that you guys are like really well prepared. All right, so that should be like, you know, a feather, all right, in your cap, and you should pat yourself on the back and tell yourself that yes, we have done so far really well. Acha, students, we have an Instagram page. This is the official link, @Unacademy JEE official. There are, you can follow us out there, and all the latest updates that Unacademy is actually up to bring a change in your life is going to be present out here. So once you start following this particular page, all right, you will always be updated about things happening with us. That's important. Please go ahead, do it. Students, I have been telling you, let's interact. Because if we do not interact, how would we know what are your problems? Well, though we know, we have been interacting with so many students, we know, but personally, why don't you also come ahead and write to us so that we get to know what is your pain area. All you need to do is download the Telegram app, and this is the URL to join the group, and go there, join the group, ask us as many questions. You can even ask your doubts on that particular platform. All right, acha. Next, I talked to you about this in the beginning of today's session, tinyurl.com/JEE mobile. Understand, it's an archive. It's an archive of all the video lectures, not just the video lectures. The PDF notes also are going to be there. So, if you're looking for something as a last minute revision, this is the best source. All right, and all this thing is free, my dear students. You're not paying anything at all for all these lectures, all these PDF notes. Fine enough? Acha. Important thing is what? See, content, we don't mind giving it to you. We want to give it to you as much as possible for free. But there is something called as the Plus subscription. Now, there is no replacement for that. Why? Why there is no replacement? Content takeaway. But if you really want to get in touch with us educators, talk to us live, all right, during a lecture series, then we know that we need to take an Unacademy subscription where there are live classes. You get to interact with the educators. Not just that, you have got live polls and leaderboard. Let me tell you, students, people find it so interesting. All right, that when there is a question and there are a lot of students from different corners of the country are actually taking part in that particular quiz, you're getting to know how much time that they are taking and where are you currently in respect to your preparation with that particular topic. It really gives you an idea that, I mean, sometimes we don't know that we need to walk, We need to sit still, or we do need to run right now in our preparation. So when you see the other students preparing really hard, you really get motivated. That is the benefit of these live polls and the leaderboard. All right. Acha, by the way, there is also your test series and lots of analysis taking place. You have got live doubt clearing sessions, so you just need to click a pic of whatever doubts you have, not just in the session but from outside as well, and you will get your doubts clarified right then and there itself. Okay. Acha, the platform for the subscription, once you have taken the subscription, you will have an access to not just me or Namo sir or Jain sir, but like all the educators who are there on this particular platform. Isn't it something that we can only think about? All right, but Unacademy has made it a reality. Just think about if you are going to a offline class. I mean, you just need to, or you had to learn from the same educator from the beginning of the 11th standard to the end of the 12th standard. That's not true anymore in this country. Any educator you want to learn from, you have the right, you have the freedom to choose him or her and move ahead in your preparation. Isn't this a blessing? Let me tell you, if you are not able to understand this particular value, okay, you will understand in time to come. Okay, guys, simple thing, if you have not downloaded the Unacademy app so far, just search for Unacademy Learning app. Press on the install button. After that, what is going to happen? Simply choose for Plus, then choose for IIT JEE and click on the subscription button. Okay, simple 3-step process. And then the 4th step, very important step, use the code SMLive. Let me tell you, use the code SMLive and right away get a 10% discount. How much? 10%. That's quite a lot here. Okay, and students, simple thing, the ones who are coming to the channel for the first time, subscribe it, very important. And do not forget to press on the bell icon, because important lectures you will be notified, right? So that's like, very, very important. And from April onwards, we are going to have all your lectures coming up in English as well. Hindi to thai. Now it is going to be in English also. What a blessing. Even people from different regions of the country who do not understand Hindi, they are also going to be benefited this year onwards. All right. So just look at the effort these people are making to get things done. All right. Acha, you will get all your notes in the PDF format. That's like super fine thing. Besides the JEE English, these are the various other channels. Go watch it. Inform the people, the neighbors, the friends, and let's say your young relatives or anyone. Just let them know. And importantly, to finish up with, students, SMLive. Do not forget this code and get right away your 10% discount. God bless you all and best of luck for your Monday's paper on your physics board examinations. Thank you and bye-bye.